Okay, let's do 5.9. And for this one, let's just draw it up as we go. So, a man with X-linked color blindness marries a woman with no history of color blindness in her family. So, here is up here up top, a man with X-linked color blindness marries a woman with no color blindness in her history of color blindness in her family. And obviously, she has wild type. So, it's X wild type, X wild type. The daughter of this couple, so here's the daughter of this couple, marries a normal man. So we know that the normal man here, XY, has a wild type allele, right? Because he has normal vision. Um, uh, and their daughter also marries a normal man. And so here we have the daughter also marrying a normal man. Here's the X chromosome with the wild type allele. And so here, let's go back to this one, this woman here. We know this woman, we know the genotype of this woman, right? She had to have inherited a colorblind allele from her father. So her genotype is XC, X wild type. Now the question is down here, and we're just going to label this individual A. What is the probability? What is the chance that this last couple has a child with color blindness? So here's the child with color blindness, and we're just going to designate this child A. And so here we know the grandmother here is a carrier. So what has to happen is that the grandmother has to pass on that mutant allele to the mother. We know the mother has regular, normal vision, is not colorblind because she had to have inherited this X chromosome, this wild type X chromosome from her father. And then the mother has to then pass on the X chromosome to the child in order for that child to be colorblind. The other condition of having that child be colorblind is that that child has to be male, so the father has to pass along that Y chromosome to the child. So it has to be a male that also gets that colorblind allele from the mother. Okay, so all of this, so here we're just going to label this individual A, this individual B. So the probability that A is colorblind is the probability that B is a carrier. That has to happen. The other thing that has to happen is that carrier has to pass down the mutant colorblind allele to the offspring, and then the father also has to pass along the Y chromosome. So there's three events that have to happen for that individual to be colorblind. And so we know probability that this individual is colorblind is if that the mother can inherit one of the two X chromosomes from the grandmother, either the wild type or the colorblind. So it's a half, it's a 50% chance that the grandmother is going to pass down that colorblind allele. It's also a 50% chance that that mother is then going to pass down that colorblind allele on the one X chromosome that contains that mutant allele. That's also one half. And there's also a one half chance that the father will then pass down the Y allele, and this individual will then be a colorblind male. And so each of these three events have to happen. So for this event and this event and this event to happen, it's one half times one half times one half equals 1/8. Okay, so that's the first part. That's the first question. The second one, if this couple if this couple has already had a child with color blindness, what is the chance that their next child will be colorblind? So all this does is say we know this event's happened, that this individual is a carrier, that the mother is a carrier because she's already had a child that is colorblind. And so all we have to do is calculate the probability then that the mother will pass down that allele to A, so that A gets passed down that allele, right? And both that mutant allele in both the Y chromosome, and so that's just you just canceling. You don't have to figure in this part, so it's just one half times one half equals 1/4. Okay, so that one's a pretty straightforward one.